How do EV friction brakes really work? Have you ever wondered how electric vehicles manage to stop safely? The answer lies in their braking systems, particularly friction brakes. Let's break it down in a simple way. Electric vehicles utilize two main types of braking systems: regenerative braking and friction braking. Regenerative braking is the star of the show, as it recovers energy while slowing down the vehicle. This process uses the electric motor to act as a generator, which helps recharge the battery. However, friction brakes play a vital role as a backup, especially in heavy-duty or emergency situations. So, how do friction brakes work in electric vehicles? They function much like those in traditional vehicles. When you press the brake pedal, brake pads press against brake discs, also known as rotors. This contact creates friction, converting the vehicle's kinetic energy into heat, which ultimately slows or stops the wheels. It's a straightforward mechanical process that relies on physical contact. In electric vehicles, friction brakes are not used as often because regenerative braking handles most of the normal slowing down. This means that the components of friction brakes tend to wear out less quickly. As a result, brake pads and discs in electric vehicles can last longer compared to those in conventional cars. However, since these brakes are used less frequently, they can accumulate rust or debris if not applied regularly. This buildup can affect their responsiveness and may lead to noise or vibrations when you do need to use them. To keep everything running smoothly, electric vehicles have electronic control systems. These systems manage the transition between regenerative and friction braking based on how you drive. For instance, gentle braking usually activates regenerative braking, while sudden stops engage the friction brakes for safety. Friction brakes in electric vehicles can also be controlled by advanced electric or electro-hydraulic systems. These systems use sensors and actuators to apply the right amount of braking force based on your input and the vehicle's dynamics. This means the brakes can adapt to different road conditions, enhancing overall performance. From a maintenance perspective, it is important to periodically use friction brakes. This helps prevent rust buildup and keeps the system responsive. Regular inspections during servicing can check for wear, corrosion, or debris. Even though regenerative braking saves energy, friction brakes are essential for those hard stops and emergencies. In summary, friction brakes in electric vehicles work by applying brake pads to discs to create friction and slow the vehicle down. They complement regenerative braking but are still vital for safety. Proper maintenance includes regular use and inspections to ensure they remain as reliable and effective.